Hey, what's up guys? Back again with another video in the Java series. This time I'm going to show you the difference between the equals equals operator and the equals method. Alright guys, so I have a little project here I've made so we can test this out, and I can demonstrate to you the difference between equals equals and the equals method. And so what I mean by that is that usually in a condition like an if statement or something like that, you have equals equals, and you use that to compare two values to see if they're equal or not. And then you also have equals, which is a method, so equals. And usually you use equals upon objects or upon strings, which are objects, right? And so what is the actual difference between equals equals and equals? Like, when should you use one and when should you use the other, right? That's an important distinction to make because they are very different. Well, not very different, but they are different. Alright, so let's do some examples here first. And what I want to show you first is a short demonstration of how you use equals equals. So let's just have some simple primitives here. So we'll have integer number 1 is equal to 8, and don't forget the semicolon. Integer number 2 is equal to 3, and then integer number 3 is equal to 8 again. So we're just going to do some simple stuff. So we're going to have a s out, and then we're going to output the condition, or the result of this condition here. So let's output the result of number 1 is equals to number 2. And by equals equals, I'll just say equals from now on, but you know what I mean because you can see what I'm typing, right? So now that's going to print true or false depending on whether number 1 is equal to number 2 or not, right? And then we'll have a second one. This time we'll say number 1 is equal to number 3. So this will be true or false depending on if number 1 is equal to number 3. So pretty basic stuff, right? So now let's do Shift F10 to run this program, and now it's going to build it and run it and all that fun stuff. There we go. So we get false and then we get true. So why is it false? Because number 1 is obviously different because 8 is not the same as 3, and then true because 8 is the same as 8. So what it's doing here is comparing the values stored inside these variables here. So the value of number 1 is 8, the value of number 2 is 3, the value of number 1 is 8, the value of number 3 is 8 also, okay? So that's all it's doing. It's just comparing the values of each variable to each other to see if they're equal or not. Now let's see what happens when we try using an object and do the same thing. So this time we'll have a name object, and we'll say name is equal to new string. And you don't have to do new string, you could just put it within quotes. That's a shorthand way of doing it. But just to make it clear that we're working with an object here, we're just going to put new string, doesn't matter. So new string Randy, and then we'll have a second one. So s out name 2, or not s out, I mean string name 2. So we're going to have a second one. So string name 2 is equal to new string, and his name is Randy also, okay? Actually we'll give him a different name. We'll call him Joe. So Joe. And now what we'll do is very similar to what we did before. We'll just compare the two things. So name 1 is equal to name 2. And then we'll do, yeah, that's good. So name 1 is equal to name 2. And let's see what happens when we run this. So Shift F10, it's just the same thing as pressing the run button. So yeah, we get false. So false is our result of this condition here. So name 1 is not equal to name 2, which makes perfect sense if you're looking at it from a simple perspective. Randy is not equal to Joe, obviously. But let's see what happens when we change this to Randy. So they both have the same character stored inside the string. So let's see what happens when we try comparing the two strings to see if name 1 is equal to name 2. So let's run the program. So why is it being false still, even though they're both Randy and they both have capital R's and everything's the same? Why is it still false? Well, that's because what this is doing here is it's not comparing the objects. It's comparing what is stored inside of this here, this variable. And you have to remember the basics of how variables work. Okay, so primitives here are pretty simple. Primitives store primitive values like 8, 3, or any number if it's an integer, right? But then you have reference types. So this is a reference variable that stores a string, right? And so a reference variable stores what? It stores a reference. So in this case, what is being compared here is not an object per se, it's a reference to an object. And if you remember what a reference is just another way of saying a memory address. So in essence, it's a memory address, right? So if these two objects here, okay, so let's just make this clear. So this is not an object. If we're speaking technically, this is not an object. It's a reference variable that stores a reference to an object, right? But just a simple way, a non-technical way, just a simple way of saying this is an object, right? But it's not really an object, right? So hopefully that makes sense. But if you're not clear on the distinction, then go back to some of the Java basics and rewatch those episodes and read up on that stuff, okay? But anyway, back to what I was saying here, what's being compared is what is stored inside the variable, which is in this case a reference, aka a memory address. So in this case, Randy the first string here, Randy, is a totally new object. It makes a new string objects and then stores the reference into that reference variable here. And then we make a second reference variable that stores another reference to a new object that happens to have the same name. So even though the objects have the same value, like they store the same characters and stuff like that, they're technically not equal in terms of what we're comparing here. So in this case, again, just to reiterate, we are comparing the references stored at the reference variable. So this is something called a shallow comparison. It's not deep comparison, it's shallow because it's only comparing the identity of the object, right? It's not really going inside the object and seeing if the members of the object are equal to one another, right? So we want to achieve something called deep comparison, which is what we can do with the equals method, okay? But first, let me just prove to you that this actually works. So let's go ahead and make a third variable, so string name3, and we're going to set name3 equal to name2. So what this will do here is take the reference that is stored inside of name2 and copy it into name3. So now name2 and name3 point to the same object in the memory, okay? They have stored the same reference, so they should be equal because, again, the references are being compared and not the objects. So let's just change this here. So name2 is equal to name3, and now we'll run this, and we should get true. And there we go, so we get true. So that's proof for you to see. Okie dokie, so let's just go ahead and check out equals, the equals method. And so we're just going to make two new strings here. So string name3 is equal to new string, and we're going to call him Rick. And then string name4 is equal to new string, and we're going to call him Dick. So Rick and Dick. And so now we're just going to compare these two things here. So in this case, let's say we actually want to compare them to see if the values stored within the objects are equal. So what we really want to be checking here is to see if the first string name3 is holding the same characters as the second string name4, which is Dick, right? So we want to see if those two things are equal. So pretty simple, right? So we can do name3 dot equals and pass in name4 as the object. As you can see, it wants an object, so we pass in an object, and what that is going to do is do a deep comparison to see if they hold the same characters or not. And this is defined. Obviously, string is part of the Java language, so the equals method is already defined. And actually, every object, the equals method is part of the object class. So every object, regardless of if it's a custom object or not, regardless of if you make the object or not, is going to have the equals method, and you can choose to override it or not to provide custom implementation or make a deep comparison of your own. And we'll see that in a second. I'll actually show you how to make your own custom equals method, okay? So anyway, what this will do is just compare the two strings to see if they are equal or not. Now it says false because they're not equal. This one says Rick and this one says Dick. So let's change the second one to Rick. Oops. So Rick, there we go. So now we'll run this again, and we get true. Because this time, what is being compared here is not the references stored at these two string reference variables, but instead the values stored inside the strings are being compared within the object itself, okay? Because the string object has overridden the equals method and provided its own implementation so that it compares each character to one another, okay? Anyway, so let's go ahead and see how we can do that ourselves. But before we do that, we actually want to check the documentation to see what the equals method is all about. So we're going to search object Java docs and pull up that on Google. So we get object here, and we have the object class. This is the Java docs for it, so we can see everything that's part of it. So we have a bunch of stuff here. We have bunch of stuff. So let's go down to equals, and let's zoom in a little bit so we can try reading it. Equals, there we go. So equals, public boolean equals, so it wants an object, it returns a boolean whether it's equals or not. And it says it indicates whether some object, or indicates whether some other object is equal to this one. The equals method implements a equivalence relation on non-null object references. It is reflexive. So these are like the basic rules of the equals method that you should follow. So it needs to be reflexive for any non-null reference value. X.equals x should return true. So it's able to be equals with itself, which makes perfect sense because an object is obviously going to be equals with itself if it has the same values inside of it. It is itself, right? Because you are yourself, right? So it's equals to itself. So anyway, symmetric. So for any non-null reference values x and y, x.equals y should return true if and only if y.equals x returns true. So it should go both ways, which makes perfect sense. it is transitive for any non-null reference x, y, and z. If x.equals y returns true and y.equals z returns true, then x.equals z should return true also, which makes sense. It is consistent for any non-null reference x and y. Multiple invocations of x.equals y consistently return true or consistently return false, provided no information used in equals comparisons on the object is modified. So it's consistent, meaning it doesn't really change unless you change the object itself. So no matter how many times you call it, it will stay consistent. It won't change. So true or false. And then for any non-null reference value x.equals null should return false, because obviously an object cannot be equals to null. That doesn't make any sense. So that should return false automatically. So then we get the equals method for class object implements the most discriminating possible equivalence relation on objects. That is, for any non-null reference values x and y, this method returns true if and only if x and y refer to the same object, x is equal to y has the value true. Note that this is generally necessary to override the hashcode method whenever this method is overridden, so as to maintain the general contract for the hashcode method, which states that the equal objects must have equal hashcodes. So yeah, usually when you override the equals method, you also want to override the hashcode method, which is another method provided by the object class. So let's go ahead and check it out. So public integer hashcode returns an integer. So it says it returns a hashcode value for the object. This method is supported for the benefit of hash tables, such as those provided by HashMap. So yeah, we don't really need to do this. It does recommend it, because if you do plan using this object for something like a hash map or some hash related table type thing, then you are going to need a hash code, because that's how hashing works for those types of data structures. But even if you don't override the hash code method, it should still work. It just won't work. Well, it depends. It really just depends. And this is really just a topic for another episode when we get into hash tables and stuff like that. But I'll show you in this episode how to override the hashcode method. Just a basic implementation of it, so we can make sure we're doing everything correctly, right? Because it does recommend that you do it, so it's might as well do it, okay? But anyway, let's get back to the equals method here. So we have all these rules down. So this means that we need to keep these in mind whenever we design our own implementation of the equals method. We need to make sure they follow these 5 rules here, okay? So let's go ahead and check that out. So in our project here, we want to create a custom class so we can test this out and make our own implementation of the equals method. So class, we'll call this person. And we'll just make some basic members here. So private string name, and then private integer age. Okay, and then we'll set up a constructor here. So code generate constructor, and some getters and some setters. So we're just making basic Pojo, plain old Java object here. So generate getter and setter. There we go. And so every person is going to have a name and an age. So that means that if they have the same name and the same age, they are equal, right? So we did not provide our own equals method yet. So let's see what happens when we try using it. Because like I said before, every object, the object class has its equals method automatically. So every object should have a equals method, even though we haven't implemented it ourselves. It should have it. So let's see what happens when we try using it, if it works or not by itself without a custom implementation. So we're making a new person here. So person1 is equal to new person, and we'll give him a name, Cody, and we'll say 19. And then second person2 is equal to new person. We'll say Henry, and he's probably like 20. So now let's just see what happens when we try comparing the two things. So person1 is equals to person2. This should obviously be false because these are totally different object references here. So it should be false, obviously. But just for demonstration purposes, we'll print it out, and yeah, we get false. Good. So now we'll just change this to equals. So person1.equals, and again, we have this method here because it's an object. Every class is an object automatically, right? Even though you don't extend the class, it's automatically an object. So it should have this method. So person2. So this will print true or false depending on whether person1 is equal to person2 or not. So F10, and we get false. So it's not equal, okay? And now let's go ahead and do person2 is equal to person1. So we're just going to copy the reference from person1 and put it into person2, which should be true because technically you're comparing the person to itself, pretty much. So yeah, that should be true. So let's try running this, see what happens. And yeah, we get true, which makes perfect sense. Now let's go back, Control Z, and change this from Cody to, or Henry to Cody, and we'll change this from 2019. So we have two different object references, but they do have, or objects rather, and object references, but they do have the same values. So let's see what happens when we try comparing these two. So F10, and we get false. So that's kind of interesting, right? So in this case, even though they do have the same values of Cody and 19, they are still false, which is not good because we like we saw before, if it's an equals, we want it to do deep comparison, right? Not shallow comparison. Again, shallow comparison is where it's testing to see if the identities are the same, meaning that the references are, the same, right? Like we saw with the equals method or operator. But in this case, we want deep comparison where it's testing to see if the values or the members of the object are the same. And so the reason it's not working how we want it to is because when you don't override the method yourself and implement it yourself, it's going to do shallow comparison by default. Because of course Java can't just, I guess it could if it really wanted to, but it can't really just generate its own implementation of the equals method. That's up to you to do. So it's going to do shallow comparison by default. So now let's make our own implementation of the equals method to try doing some deep comparison to compare the actual members of this person, class, or object, whatever. So now we'll do public, and it already gives you a suggestion here, so equals. And as you can see, IntelliJ actually offers to override the equals in the hashcode method for you, so you don't have to go through it all yourself. So if we just do this, so next, and these are just us choosing what we want to be compared in each method. And then in the hashcode method, we're just saying what values we want to use to hash it. So next, and then finish. And so what this will do is generate the two methods for you. So in this case, we get equals, and this is pretty solid, right? So this follows the rules. So if we bring the rules back up that we had a second ago, let me find it. So right here, the first one is, maybe not the first one, but the last one, for any non-null reference x, x dot equals null should return false, and that's actually the first thing it does. Or no, it's the second thing it does. So if O is equal to null, then it automatically returns false, right? And then if this is equal to itself, then it'll return true because that is the first rule. So it is reflexive. So for any non-null reference x, x dot equals x should return true because something is obviously going to be equal to itself if you compare it to itself. So also we can see that it has the getClass method being compared to the getClass method of the parameter that's being passed in, just to see if they're the same class or not. And if it is the same class, and if it gets past these two lines here, then it'll go to this line where it makes a new person and just cast this object into a person object. So this is just an object, and it's just casting this person or this object into a person object, right? So we can work with it. So now what it's going to do is just return true or false if age is equal to person.age, which is the member of this class here, and also if the string of name is equal to the string person.name, which is the parameter that is passed in. And we can even just rewrite this to something name.equals and then pass in person.name. So that's the equivalent thing you could do if you want to. It doesn't really matter. So all that is really doing is just comparing the two members to see if they are the same. And of course, if two persons are equal, then they of course will have the same name and the same age. Otherwise, a person cannot be equal, right? So that makes perfect sense. So if they have the same members and the members are equal, then they're obviously going to be equal and that will return true. So yep, that's how that works. And then we have this hash code method that was generated, and all that is doing is returning objects.hash, which is a method added in, I believe, Java 8, either 7 or 8. I think this hash method was added that automatically returns a hash integer for the members that you pass in. So it's just a very simple method that will automatically hash it for you, so you don't have to worry about the implementation yourself. So yeah, that's the basic implementation for the hash code method I told you I would show you. Basically IntelliJ did all the work for us, but anyway, just remember that anytime you want to hash an object, you can use objects.hash, which is a very simple method where you just pass in all of the values that you want to hash, okay? And again, this is just for hash tables and hash maps and all that stuff. You don't really have to worry about this for this episode. What we're really worried about is the equals method and how to use it properly. And yeah, so this is just a simple implementation for that. So now let's just go ahead and try running this now to see if this returns true. Because person 1 and person 2 do have the same members, So they should be true now. So let's run the program. And there we go, so we get true. So before it said false because it was doing shallow comparison, but now since we've implemented the equals method and it's comparing each member and all that fun stuff, it is true because it's doing deep comparison. And let's just go ahead and change this back to another name like Henry, and we'll leave it as 19, and it should say false now because these two members are obviously not true anymore. I mean, the age is true. I mean, well, by true I mean it's the same value, but the name is not true anymore. I mean, the same, so it's not going to be true in terms of its equality, right? Because every member needs to be the same according to our implementation here. So if we do Shift F10 to run this program, we should get false, and there we go, we get false. So something you should keep in mind is that since you're providing your own implementation, it does not have to compare each member. It doesn't need to. It also doesn't even need to follow the rules. I mean, you're supposed to follow these rules because that's the proper way to do it, but you don't have to. It's up to you. It's your program. But the most important thing is that you don't have to compare each member to see if they're equal. It really depends on how you design your program and what each object is all about, right? So not all classes are the same. It won't make sense for every class to be equal if they have all the same members that are equal, right? So some classes are very complex. They have many different components to it. So for one object of that class to be equal to another object of that class, it won't make sense every time for all of the members to be equal to one another. I hope that makes sense. But the point is that you can define this however you want to, whatever makes sense for your program, right? It's your program, your world, just whatever makes sense to your design specifications, all right? And that's it. That's all I want to show you for this episode. So now you know how to properly use equals and the equals method. Okay, so just to recap, the equals operator is just for comparing the value stored at a variable. So in this case, if it's a primitive, it'll just see if the two primitives stored at that variable are the same. And then if it's a reference variable, it'll just see if the references are the same. So if they have the same address or not, if they're pointing to the same object. So you got to remember that, you know, the reference variable basics when it comes to that. And just remember to always use the equals method whenever you're comparing objects in terms of their values, not their identity. So that will be deep comparison. So, and then also you want to usually, if you provide a custom equals implementation, usually want to also provide a hash code implementation recommended by the, the Java docs and all that. And all you really need to do is just do objects.hash, and that'll do the hashing for you. So you don't really have to do anything special anymore in newer programs, okay? And you can provide custom implementation just like you can for this one too. You can do exactly whatever you want, okay? Whatever you think is best. And we'll make a separate video on how hashing works in the future and all that fun stuff, okay? But anyway, I hope you enjoyed this episode. I hope you liked it. So what I'll do is leave a link in the description below to see the code for this episode so that you can come back to it later on. You can bookmark it and see the concepts again in more detail without having to rewatch the whole video. And all that fun stuff. So also I'll leave a link for my Discord server, so if you want to join the community, you can click the link and then join it and get some friends if you don't have any, or get help on your programming stuff, and whatever you want to do, just join the community and hang out with us, okay? And also if you want to support this channel, you can click the join button below this video, and you can join this channel as a member for 99 cents, $5 or $10 a month, and you can cancel anytime. And you get really cool perks like a cool rank on my Discord server like we see right here. Let me pull it up real quick. So right here we have a cool rank. So we have the YouTube member rank, so you can get that rank if you want to. And also another cool perk is that you get early access to all of my new videos before everyone else. So if you want to get access to this video and videos like it before everyone else, you can become a member and sign up and everything like that, okay? And yeah, and also you get to see yourself on the screen like you do right now. You can see all the members that are currently signed up. So thanks to you guys, and thanks to everyone else who has subscribed and liked the videos, and thank you for all the support. And that's it. So if you like this video, leave a like. If you want to see more, subscribe, and peace.